Okay, okay, welcome back everyone. I hope you had a refreshing tea break. Now, as we move towards the final stage of this wonderful week of learning, we are once again joined by none other than Professor Rajiv Asthana sir for his last but not the least session with us. In this session, sir will speaking on a topic that's close to every academician and research hearts. Topics for joint research, future trends in additive manufacturing, publication strategies, and grant writing. Sir, it has been an absolute privilege to learn from you throughout this session. We will look forward to this final session with great enthusiasm. The stage is yours, sir. Thank you very much. Yes.
Thank you. Thank you.
Uh,
I will use these arrows here.
yes, sir.
For
For moving the
Thank you. So, excuse me. Good morning, everyone. Again, glad to be here. And this kind of a topic that I'm going to talk about is a little bit of a deviation from your main focus. Additive manufacturing, but also other implications of your research and how you can communicate it to other people. So in this presentation, I have a few slides where I'm just going to first talk about my university and what kind of work we do, how we do research and education. And after that, I will give some information about how young faculty, new faculty starting their career, how they can get involved and conduct research and publish work. And then finally, I will just wrap up my presentation with a short discussion about a journal that I edit, in which Professor Banerjee is also involved, and how you can get your work published in that kind of a journal. So those three areas I'm going to look at. So on this slide, I have pictures of my university. Um, this is a campus that is around a lake, and in peak winter, the entire lake freezes, so it becomes solid, and the whole campus becomes white. But these are the pictures in spring. So our university is technically a polytechnic university, and this is the only polytechnic Okay. Yes. Okay. Thank you. All right. So let's just go back where we were. And I don't think there is a lot of loss if there are interruptions, because this is more like a general overview and discussion. It's not something technical that we need to be maintaining continuity on. So please bear with me if this happens again. But just to let you know that, yeah, we have our students, undergraduate students involved in research. They have access to all the state of the art equipment that we have on campus. And for example, I remember just now, there is a girl who is doing some research on space junk. She was my student last semester. So a lot of times space debris falls on the Earth. Not all of it burns out during re-entry. And quite often you find big pieces of carbon composite panels or everything lying somewhere in the desert or someplace. So what she's trying to do is she's trying to develop some catalyst that will speed up the degradation of carbon before it reaches the ground, the Earth. So that's a very practical problem, and she came up with that problem statement on her own. She was reading in the media that there is a lot of space junk falling. What can be done about it? Because not all the carbon burns out in space. So she came up with that idea and she's doing that research. So our students, they look for more practical opportunities for research, and they are encouraged to involve in research because it's a good resume building exercise. And also, it gives them, it looks good on the for the graduate school application. They are able to develop presentation skills, writing skills, and also by conducting research, our undergraduate students are able to use equipment for an extended period of time, not just during the class time, but outside of the class time. So that's another reason why we encourage research. And then they can also, learn about how to plan and conduct research. So let's switch gears. And this is just a summary of some thoughts I had about the younger faculty who are probably in attendance here today. So I believe a lot of people are beginning their career in teaching. So one thing is to collaborate. Collaboration in engineering technology is the most important thing. Unless you are a pure theoretician doing your own independent modeling work, you better relate to the people. So collaborative research is what is really most important. And the collaboration could be within the university or institute or outside or both, or with business and industry also. So that is one thing I emphasize the most. Collaborate, don't go alone on your own. The second point is that you must make sure to align your vision of research with the requirements or mandate of your institute. If there is a disconnect between what the institution wants in your research versus what you want, then you will never be very productive. So align your research vision with the vision of your institute. And that is usually not a problem, because when a university or institute hires you, they know your background. So when they hire you, the expectation is that you will build up research in your area of expertise. So that is another thing to look at. Third point is that uh, you should consider availability of PhD or master's or postdoc students a privilege, not a right as a faculty member. That's very important, because a lot of times, even in the United States and elsewhere, in good universities, not all professors have PhD students. And I'm not talking about teaching schools, I'm talking about regular research schools. So you are privileged if you have student, postdoc, and grad students, master, PhD. Work with them closely, mentor them, and get good work done by them. That's very important. Another thing is network, participate, and contribute to the profession. So step out. I know it's hard sometimes to attend conferences because funding has to be there and a lot of other things, but uh, as much as possible, step out, network, and do things. If necessary, you may have to spend your own money. If you're really fired up, if you have vision, you can spend a little bit of your own money to travel domestically and go and present or meet people. But generally, institutes are very helpful and they provide travel support and other things. So the bottom line is become a part of the network of your profession and contribute in different ways. And funding agencies, as far as grant writing is concerned, funding agencies, they encourage collaboration between universities and industry. At least in the US, I have seen that because in the past, when I sat on some review panels in Washington, D.C., either for Departments of Energy or National Science Foundation, I saw that any grants 1 million or more will have collaborator from industry, very strong industry component. Uh, so unless you're a Nobel Prize winner, then you can attract funding on your own. But in the normal case, you need to have that kind of a thing. So need-based research is critical. What industry and business need. Now, I'm talking about research, not troubleshooting work. Troubleshooting for industry can be done as a consultant. You can do that work as a consultant and get paid or whatever. I'm talking about research where you actually have to, get grants on campus and produce some original work. So that should be need-based research. A little bit about publishing research in a refereed journal. Mostly reviewers and editors look for some element of novelty in your work. If you are pretty much repeating what has been done, it's not very positive thing. So you need to have some element of novelty, and you need to explain the need and significance of your work in context of the state of the art. So from that point of view, the introduction part of your paper is really critical. Sometimes we think introduction is just a side thing. The main focus is in data and results and analysis. No, that's not true. Reviewers and editors first look at your introduction. And if that doesn't appeal to them, they just turn it down right away. So the well-written introduction is really critical. If that is where you explain how your work is different from or improvement upon the state of the art. So can your research impact further research, or can it contribute to industry in some way? And then other regular things about research design, experimental and theoretical methodology, and your results and observations. Any data should be reproducible, and you should have enough information for anyone else who's reading your paper to be able to repeat your experimental work. So sufficient details are needed, but definitely you don't want to put pictures of standard testers. You want to explain how those equipment were used, operating parameters, model, make, that is fine, but not just the pictures of the equipment. So analysis, interpretation, explanation, that should give evidence of depth, rigor, and some fresh insight, which means when you have a set of data that you generated, can you place it in context of other works? Can you compare and contrast your results with previous results? Do you have a model that you developed that can be used to compare the data, or is there a model in the literature that you can call out to compare your results with that? So something that is not just describing your results, but something that gives evidence of your fresh thinking and a fresh outlook. That is what we look for. And finally, a paper should be well written. So structure, clarity, flow, grammar, quality of images, and those kind of things also are important. Because when a reviewer gives a look at it to your paper, they don't start reading first. They just scan through the pages and they look at graphs and figures and other things. If something stands out in the sense negative way, then they won't even read your paper. So a well-prepared manuscript is important. If you are thinking of writing a review paper, please note that review papers are held to even stricter standard than regular research papers. The reason being the reviews get cited quite a lot, and the editors and reviewers want to make sure that you have a very well-prepared review. So most often, just submitting a literature review chapter of a thesis or a book chapter as a journal paper does not work. There's a difference between a journal review paper and a chapter in a thesis. Thesis chapter should be condensed, written very concisely, and you should add something from your side when you discuss these literature results in a review paper. So uh, one example of how you do that is in the third point, third bullet here. You can use some figures from the published sources or from your own research, but it's important that you create new graphs using the data from the literature from multiple sources and select the parameters to graph those data. Not just compile the data, but collect those data, organize those data in such a way that you can reveal trends, patterns, correlation, and some relationships. So just lifting figures, some graphs from different papers and putting them in your paper, review paper doesn't work much. I mean, you can use some figures. You have to use figures from the literature sources. But in addition to those, you must be able to create graphs where you are compiling data from many sources and not just compiling, you are putting them in a way that you can show some patterns and trends. That's what we look for in review. Also, you want to avoid repeating or regurgitating a lot of basic textbook information in a review paper because your paper will be read by professionals, not just the students. So should have a higher level. And you should provide some evidence that you have contributed to that topic originally. In other words, you should first do some research in an area before you start writing review papers. Because if you're writing a review paper as a student only, that doesn't work well. You must have made contribution to an area before you write a review. Okay. It's not a requirement, but it is expected. And you want to explain the need and timeliness of the competing review papers. If there are other review papers on the same topic, then you cannot just say, okay, I'm going to write another review paper. No, you have to justify why your review paper is needed when there are 3 other review papers in the literature on that topic. So place your work in a competitive way against other review papers. And finally, you want to be able to predict future developments in your topic. And that is something for which you have to have a certain vision, experience in that area. So if you're just starting your career and you don't have much experience in that area, it is a good idea to involve someone who has experience in that area to write the review paper. So you can provide more, thoughtful suggestions for future work. And just the last few slides here are about engineering education and research in general. Project-based learning is what is being encouraged everywhere. So instead of just lecture and solving problems on a topic from the book, people are now encouraging more project-based learning, which means you select a problem, have students work on a problem, and as they work on the problem, they start pulling information from books and other things. So focus on the problem and then learn the content about the subject. Involve industry experts as professors of practice to establish or promote collaboration. So I'm sure it is done here in India, in the US also. A lot of universities, they have professors of practice, which means experienced industry professionals. They become adjunct faculty for students. Also involve industry leaders and advisory boards, not just at the university level, but at the program level also. So like in our case, we have our Department of Engineering and Technology and 5 or 6 degree programs. Each of those degree programs, mechanical or this and that, each of those programs has an advisory board in which we have faculty and people from industry. So we redesign our curriculum so that we can incorporate industrial practitioners' needs in our courses. And you want to promote higher education that has purpose and value, not just granting degrees and diplomas. And this is something that as a young faculty we cannot do, but we have to do something or encourage our management and administration to increase private investment in higher education. And we know that a lot of private businesses put money in colleges and universities, they establish institutes and other things. But you have to remember that you don't want institutions to become training schools for private businesses. It's a very fine balancing act that you want to involve industry more and more in your academic work, but at the same time, you want to have your own autonomy and independence as academics. You don't want to become a training school for this company or that company. So that fine balance has to be maintained. And reward faculty-student collaborative partnerships to incubate new ideas and hire faculty and staff that have entrepreneurial bent of mind, who want to do something that can launch a business or something else. And I think I'm not sure about NIT, but I'm sure you also have here and other places you have incubator programs, and people who are online, I'm sure their institutes might also have incubators where faculty and student research is incubated to a prototype level that can eventually launch an actual company or something. So entrepreneurial mindset is really critical. All right, that brings me to the very last set of slides for my discussion here. A little bit about the journal and a society that launched the journal. So this society called American Society for Materials, it has been in existence for about 120 years or so. Now it is called ASM International. Uh, this is the world's largest resource for the advancement of materials knowledge. So ASM International is the world's largest materials information society. And they have many different kinds of resources available. This is the home page of the society. I just screen printed that one here. The society has many databases on all kinds of things, data solutions, digital libraries, just like ASME or ASEE and other things. So they also have these journals. ASM has 9 journals they publish. 3 of these journals are published jointly with other societies, ASM with other societies, but 6 of these journals are published or owned solely by ASM International. And one of the journals is the Journal of Materials Engineering and Performance, which is the journal that I edit, and Professor Malay Banerjee is involved on the editorial team. Again, this is the homepage of the journal. It's a growing journal. We get about 6,000 papers or more each year from about 75 countries around the world. And it's a very broad-based journal. It's not a journal specifically on failure analysis or thermodynamics or something. It's a very broad-based, practical, applied journal. So if you're interested to submit something, go online and look up these information there. Last year, we had 1.5 million downloads of papers that were published that year. And our impact factor is slowly going up. So we have an editorial board, just like any journal. We have editors, associate editors, and then editorial committee. And these are the people we'll draw. We draw from all over the world, specialists in different parts of materials area. Professor Banerjee is also involved here, as you can see. So this is our editorial team mainly. I serve as the editor-in-chief of the journal. And Dr. Frazier, Bill Frazier, he's a very senior scientist. He was chief scientist with the US Navy, and he was also president of ASM International. And then he was associate editor with us for a long time. But then when he retired from his job, then I asked him to join us as an editor. So he's with me. And these are our associate editors. We needed someone in that rank. So I requested Professor Banerjee to join us. And he was willing to help us out. So he is one of the associate editors. So we have right now 7 associate editors, and then 1 editor, 1 EIC, and a lot of editorial board members. So in addition to regular papers and review papers, we bring out special issues on specific topics. So these are some of the ongoing special issues. They're currently in progress. Advanced materials manufacturing, additive manufacturing for space and aerospace. This is another one that is going to come up. people are submitting their papers and everything. And then some specialized conferences on materials and manufacturing processes for power plants. This is from US Electric Power Research Institute. Uh, this is from Italy, dynamic response and failure of composites, advances in dissimilar welding. This is from India and someone from Poland. We did not have any special issue on welding, and we get a lot of regular papers on welding in the journal. So we decided that, okay, we may have a special issue devoted to welding broadly. So that's another issue that's coming up. And then nano joining, micro joining, European Congress on Advanced Materials. Sustainability is a big push. So we are looking at sustainability in green manufacturing in the context of materials engineering. And we have some special issues coming up there. And there's some conferences that have materials component. So when we have editorial board members on our journal, we have about 30 editorial board members, and they are on a 3-year rotation basis. Depending on our needs and their interest, we may renew the membership. But for us, editorial board membership is not just a ceremonial title. It's not something like an honor that, okay, you're on the board. These people are very actively contributing to the growth of the journal, not just by reviewing papers. We have thousands of reviewers outside these 30 people, but also these people are part of these two groups. One group is called Scope and Standardization subgroup, and the other is Quality Monitoring subgroup. So these groups, so 30 people have 15 in each group, and both groups meet online every 3 months. Each month, each member of these teams are assigned 2 to 3 published papers, and they are asked to evaluate those papers. The paper is already published, and now these people are evaluating the published paper. What should have been done? What needs to be done to improve? So that kind of a feedback is very critical. And then these teams provide their outcomes to me and Bill Frazier, and then we make a decision on how we should move forward with that data. So membership on this board is very involved. You have to be very active in that. And then apart from this, we meet once a year, the full editorial board, the society staff, publishers, representatives, all of us meet for a day, half a day or so, physically at some place in the US. So Professor Banerjee, whenever he's possible, he comes and attends the meeting there. So I think that's pretty much all I had. Yeah, this just a cartoon here, we can skip that. So I think that's pretty much all. Again, it was short, but I'm done. Is it okay? Okay, sir. Yeah.
So online participant, if you have any queries from Professor Rajiv Asthana sir, you may write the queries in chat box. So sir will be happy to. So, so please, if you have any queries, participants, if you have any queries, you can put your queries in chat box. And offline participants, you also may ask your queries to sir.
Yeah, sure. So I can read the comments here.
Yes,
If
yes.
oh, okay. Can you just set it? Yeah.